Oh, oh no, that's a disaster. I wasn't. My mic. Okay, anyway, we haven't started anything yet. I'm just going to figure out how to live reload Zig build. Yeah. Um, there we go. Our music here is. I'm trying out cause I remember that Kenny is Kenny has audio assets, so I'm gonna try to use those just for some background music here. Let me try editing something. There we go. There we go. Um, so this the problem here is let me let me reorient myself. So yeah. For now we are continuing our journey yesterday with Ziglings and believe it or not, sometimes things go wrong in programs. In Zig, an error is a value. There's a name so we can identify things that can go wrong. Errors are created in error sets. Ah, error sets. Which are just a collection of named errors. Um, we have the start of an error set, but we're missing the condition too small. Okay. You have an error set but assuming condition too small, missing edit where it's needed. My number is. Oh, this is an error set. Okay. So this is an error set. We have too small here. And okay. So the so number error here is um my number error too small. I think that should do it, but we're not refreshing here. Oh, oh, maybe. Okay. No, 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 no. How do you exit this? Okay, that just exited the split window. Um, terminal. What's this? It's terminal. Zig build. Maybe I don't want Zig build. I want Zig build, but we want to clear the terminal. Can we do that? Do that? Do that. Okay. What's English? What is English? Okay. Maybe it's running now. Let's see. Okay, so it's running now. Okay, that's good. I'm just gonna leave some message here. Uh, okay. So I think that should be it. Let's move on. Exercise 22. Remember, this is 100. 116 exercises. A common case for errors is a situation where you're expecting to have a value or something has gone wrong. I think this is similar to result in Rust. Um, mm, and var text equals this is text. What happens if get text can find food that text? How do you express this using? Nick lets us make what's called an error union, which is a value. Could be either a regular value or an error file instead. I think this is like a result in Rust. So this is an error set, and this is the value. For now, let's just see if we can try making an error union. So, so the error union is my number error. So this is a type, and the value is maybe EU8. Oh, the character is exclamation point. I think that's fine. Except my number will need to either store a number of or an error. Okay. So this is an error type or a number type. I'm still listening to Made, by the way. That's crazy. I'm trying to talk, but I can't concentrate on what I'm doing. One way one way to deal with error is just to catch any error and replace it with a default value. Okay, so that's like unwrap or default. So that's like unwrap or default in Rust. So can fail catch set. This is just unwrap or default in Rust. If can fail fails fully equals 6. It's crazy because you know why it's crazy? Because Rust just has this just has these as functions. But here in the Zigland, they're in Zigland their syntax. Their basic syntax. So my number error is too small. Add 20 catch 22. Maybe this is also catch. Cache. This is the return type from this function is an error union of my number error or a number. Maybe you can use 8. It's n plus 20. N plus 20. What am I looking at? Too small for found. Oh, it's U32. Okay, so it could be U32. Okay, so that passed 023. Actually, what the fuck is that sound effect? Anyway, um, using catch to replace an error with a default value is a bit of a blunt instrument since it doesn't matter what the error is. Catch lets us capture the error value and perform additional actions with this for. So, oh, it's kind of like map. So it's unwrap. So this is map error in Rust. This is map error in Rust coupled with unwrap or default maybe. Um, No, it's not unwrap or default, but it's not exactly unwrap or default like also in the previous example, but it's kind of like there. It's something adjacent to that. Um, so this is syntax for catching an error and doing something with it. Anyway, um, boy, catch zero below is a temporary hack to deal with make just rights. The silly example with the responsibility of making a number just right into four functions. Make just right, fix the bin, fix too small, or detect problems. Oh dear, this is missing a lot. But don't worry, it's nearly identical to fix too big. Oh. Okay, if we get two small errors, we should return 10. If we get any other, we should return that error. Otherwise, we return the user shipping number. I didn't catch how to return a value from a function because in Rust you just use our expression. I think we need to explicitly use the return keyword here. This is catch error, and if error equals I chop if error equals my number error. Good. So this is calling the variance of error union. If it's too small, we should return 10. Otherwise, we return the error. Okay, I think that's supposed to fix the problem. Right. This is catch 0. Let's make just right 4 to 4 times 0, 8 and 4. Anyway, moving on. I think this has a handy try shortcut for this common error handling pattern. Can fail catch or return error, which can be more compact and written as try can fail, which is it's just gonna return the error if it's an error. Oh, it's kind of like the what you call it the in JavaScript and C sharp. It's not throw. It's a throw keyword, and in Rust it's the question mark keyword. But it's not. I mean, in JavaScript and C sharp land, it's not gonna throw the error. You have to try first try and catch the error and throw the error. No, that's not it. Anyway, I think you get the idea, but it's kind of like the question mark in Rust. Main void. This function returns needs to return any error which might come back from the thing. It's just a try statement rather than a catch. Kakinash to the catch. That's simple. It's just gonna return the error if there's an error here. Otherwise, it's gonna add 5. Okay. Great news, now we know enough to understand a real hello program in Zing. One that uses the system standard out procedures, which can fail. Standard out. Take note that this main definition now returns exclamation point void. I'm gonna call that bang. I'm gonna call that bang like the Primogen. So it returns bang void rather than just void. Since there's no specific error type, this means that Zig will infer the error type. This is appropriate in the case of main, but can make a function harder or even impossible to work with in some situations. But this is an inferred error set. But this is gonna infer the error type if error type is just not present here. Instance for output input output operations, we'll learn more about this later. This is not size to there we go. We get the writer for standard out standard right SD out writer this writer over here and instruct interface so its interface 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 so we can interface. How do you pronounce interface? Okay. How do you pronounce interface? Interf interface. Interface. Okay, interface. Interface. Okay. Hmm. Okay, we get our represented out and instruct this interface so we can print to it. So this is the interface. Um, Unlike STD that the bug that print the standard outrider can fail with an error, we don't care what the error is. We want to be able to pass it up as a return value of main. Just learn single student. Fine. Fine. Okay. Next is differ. This is the part that I know most about physics. Actually, differ. You can assign some code to run after a block of code exits by deferring it with a differ statement. Differ run later or now, and something above. Run later will run when the block is finished. So the code above will run in a value order. This feature seems strange at first, but we'll see how it could be useful in the next exercise. Without changing anything else, we added the first statement to this code so that our program prints 1, 2. Okay. Can you defer this? Okay, number 28. Now that you know how defer works, let's do something more interesting with it. This function is supposed to print an animal name in parentheses like goat. But we somehow need to print the end parentheses even though this function can turn in 4 different places. We somehow need to print the end parentheses. Okay. So we're gonna defer the end parentheses. Okay. Seems fine. These are the animals. Okay, it's 29. That seems fine in the output here. We passed. So now, another common problem is a block of code that could exit in multiple places due to an error, but it needs to do something before it exits. automatically to clean up after itself. An error defer is a defer that only runs if the block exits with an error. Error defer cleanup try can fail. The cleanup function is called only if the try statement returns an error produced by can fail. Okay. Simply quit the core program if you fail to get a number. Okay. So please make the failed message print only if the make number function exits with an error. Let's pick fail, try get number. This could also play print this number. So we need to error defer the failed function. Let me turn off some. Get out of here, Clanter. Wait, that doesn't exit. Okay. It doesn't exit the thing. We need to do something else first. So oh, there's fucking why did it do this? Okay, now it should be disabled. Start this. Oh, I just noticed this. It doesn't fit on the doesn't fit on the window. This is exercise and we're here at Air Defer. And this should be the term. Oh yeah. Okay. That's what I did anyway, but I remembered it won't work. Okay, I was just interacting with someone. Okay. Okay, is this working? Okay, where were we? This is fine. To the exercise 20. We move on to exercise 30. Switch statement that should match possible values of an expression. Oh, the switch statement. Okay, this should be easy. We have match in rows. And switch in JavaScript and C#. So this should be easy. And note that this is not default here, this is else. This is else here. And this is an arrow, a big fat arrow there. And this is switch C. state instantly exhaustive. 26, 9, 7, and 42. So we need a 42 branch here, but the comment tells us to just use else. We can use else. Print a question mark. We print a question mark. We're just gonna copy the examples of the here. SCD to the button. Okay, we just copied that. Okay, zig question mark. Okay, 31. What's really nice is you can use a switch statement as an expression to return a value. Okay, that's just like Rust and Coffee script. Okay. As in the last exercise, please add the else, and this time I better return an exclamation mark. Okay. Copy. Look out. What's really nice? Let's move on. Zig has an unreachable statement. Okay. So that's kind of like the unreachable macro in Rust. Okay. Use it in a tell the compiler the project code should never be executed, and the mere act of reaching it is an error. Okay. So there's a little virtual machine that performs mathematical operation on a single numeric value. Switch statement doesn't cover every possible value of a U8 number. We know there are only 3 operations, but Zig doesn't. Use the unreachable statement to make the switch or else. Okay, so we need an else unreachable. Okay, that's easy. That's easy, and it also kind of types. It kind of like types or forces the U8 type to a specific domain. So it's kind of like TypeScript in that way. Um, okay, let's revisit the first error exercise. This time we're going to look at an error handling variation of the if statement. If value error handling variation is so this is a error value combination. So it's like the result in Rust, but you give a value and you give an error as well here. It's kind of complicated syntax, and I prefer the Rust syntax, to be honest. This is kind of like unnecessary. It's whatever. I want it that way. Let them have their fun. We'll take it even further and use a switch statement to handle the error types. Okay, fine. Number may be fail, return error union rather than straight error. Okay, so this is static here. Please add a match for too small here and have it print less than 4. So this is my number error. Too small. I need it for the folder print less than 4. Okay, that should do it. This is a value. So there's a value right here and print in the value. This is 4 equals 4 here. Okay, quiz 4. See if you can make this program work. Solve this any way you like. Just be sure the output is my underscore num plus 42. Oh! So, get number false. If false, return error that illegal number. No, this is just a pass-through. Okay, so this is just value then. It's out. Let's get number. The type of this is num error. Bang U32. Okay, can't print error union without a specifier. This is maybe this is try. Bang or any. This is just U32 then. Okay. Okay. Good. Remember that little mathematical virtual machine we made. So we're not using opcode. Have to use unreachable. Okay, so we introduced the concept of enums. We have enums in TypeScript and Rust and C Sharp and maybe Java. I haven't touched Java in a long time. Let's complete the enum. This is I can see the operations here. There are operations here. So this is ink, deck, and pow. Insert the comma. Let's not insert a comma for now. Okay, that passed. I haven't read everything yet. I haven't read everything yet. So there's no else moving here. That's fine. Enums are just a set of numbers. You can leave the numbering up to the compiler or assign them explicitly. You can even specify the numeric type used. Okay, you can get the integer out with a built-in function at int from enum. Const my stuff u8 equals at int from enum stuff that look how that built-in function starts with n, just like an input function you'd be using. Hex, we can write in hex. Please define and use a pure blue value color. Fine. This is okay, so int enum is okay, we edit here. I was looking at this cause this is missing something. What is this? This add is formatting to the blue value. Okay. X is the value, colon is a separator, padding character, alignment, width. Okay, so this is just okay. Moving on, being able to group values together let us turn this into this. Okay, so this is just a struct. This is just a struct. Okay. Use an enum to specify the character role. Wizard, thief, bard, or warrior. Just add a new property to this struct called health. Okay, so health and make it a UA. You sure UA? Do this fine. This initial is globe with 100 health. Oh, I'm sorry about that. Drop getting some gold. A wizard has. Okay. Number 38. 38. Character. Character. Please add Jump the Loud with the following properties. Oh, it blew out. Blew up here. What? Is this segmentation fault or something? Hmm. Why did it blow up? I'm gonna edit it again. Oh, it's just kinda stat. What number is this? It's 286,000. No, 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 no. What? 2 billion. 163,311,530. This is just U32 thing. I don't think so. We lose something. Oh, it just writes this. It just writes this. So maybe we format this as hexadecimal. How did we format this earlier? X then 0. This is just padding. But this is X. I'm just curious. What will happen? Okay, it's just outputting a bunch of A's. Bless. Okay. It's just outputting a bunch of A's if it's undefined. Okay. Oh, why am I sleepy? Okay. It might be time for coffee. Might be time for coffee. I said this is cars 1 is character. The role is roll the farm. The gold is 10. The health is 100. And experience is 10. So this is debug mode, but if it's not debug mode, it's just gonna panic, I guess, or sag fault. Maybe it's gonna sag fault. Let's remove the format here. Oh, it's 20 experience. Okay, going to what is that? What was that? What was that? I am not moving anything. Check this out. Miss fire. Oh no. Oh no. Pointers. Oh no. Pointers. Oh no. Pointers. I'm just gonna. I'm not gonna explain pointers to you. I'm not, I'm not gonna explain pointers to you. Let's see what this is referring to. Please make num2 equal 5 using num1 pointer. Okay. So this is gonna be num1. But num1 is a UA. Oh, we need to use num1 pointer. Why did this fail? Is there a code checker here going on? Oh, it wants us to use the unused. What will happen? What will happen if a comment says? Um, I made it put them to BRB. Okay, it doesn't want me to. Doesn't want me to do that. You can even see what I'm doing. Oh no, you can see what I'm doing. Okay, I'm gonna move myself over here. Okay, that's better. This is always use this portion. Okay, this is slightly better. There we go. I made coffee. Okay, what are we dealing with here? This is the reference num1 pointer. Unresolved, unable to resolve comp time value num1 pointer. What's the answer here? What's the answer here? I know. We're using a different syntax for dereferencing, so we need to dereference this pointer. That's different from C. Okay, that's different from Rust. Okay. This is slightly more ergonomic because it's clear what we're doing. Okay, number 40. Important to note that variable pointers and constant pointers are different types. Okay. I'm sorry, I'm just drinking coffee. Can't make a bar pointer point to a beautiful value. Okay, so what's the problem here? Expected type pointer U8 found pointer confluent. Huh. Really? Is that it? Oh. So yep. so if if you have a cons pointer or something, it should be mutable, I guess. I didn't get that. I didn't get that at all. Okay, the tricky part is that the pointer's mutability. First, with the ability to change what the pointer points, and the ability to change the value at that. Ah, so to change the pointer. Huh. Excuse me. Please define pointer. Please define pointer P so that it can point to either foo or bar and change the value. Points to. This is a bar. This is a pointer to the pointer to a U8 value was undefined. I defined this only. No. How would I define pointers again? Okay, that should be it. I think I understand that bit. Pass by reference when you want to change the pointed to value, otherwise pass the value. Okay. Let's pass the number reference to our function and print it. Make fan. Or make 5 this. Print the array. I think this is x. The reference x. The reference x equals 5. How do how is this it? Oh! I just guessed that. I think that's it. So you can assign to this the reference. Okay. As with integers, you can pass a pointer to a struct you wish. When you wish to modify that struct, pointers are also useful when you need to store a reference of struct. Vertex equals struct. Did I undo something? Note that you don't need to reference the point to the access structs. Oh, that's okay. That's fine. You can write functions that take pointers to struct. Pointers usable you need to send to struct. Purpose positive or showing minus show. You write functions that take pointers to structs are used. Two function modify struct v. Okay, that's fine. Okay. You can provide default values. I need to use question mark here to allow for a null value. But I don't explain it until later. Please don't tell anyone. I'm gonna tell the president of I'm gonna tell the president of whatever. I'm gonna tell the president of the European Commission. Hmm, no, I'm just joking. Please don't ban me. Mighty Crowdor. Glorp. Mark. Mark Glorp evolves. Possibly their own experience. And the mentor is Mighty Crowdor. Fix me. Please, please, please pass door to print card. Okay. Simply, please pass door here. Is that it? Note how this function C parameter is a pointer to character store. Okay. Meta Wizard G 10,000 H 100 X 2340. Checking the optional value and capturing it will explain later. Spares me the question mark. Let's see that mentor. So the print character. Why did we need null here? Oh, this is a field. This is a field. Elephants walking along the trails are holding hands by holding tails. From Holding Hands by Lenore Emling. Uh-oh. What is this? Uh-oh. Make the elephants of the each tail point to the next elephant. They make a circle. Okay. Just link elephant wisdom to elephant here. Okay. I'm not learning anything. Whoa, what happened? What happened? What happened? Okay. Thank you for following. I, I got jump scared. Okay, but why didn't it appear here? My scene. Hold on. I got jump scared. Sorry about that. Uh, that's hilarious. I got jump scared by my own sound alert. Where is that? Why did it appear in my my stuff here? Is it? It's in another. It's in another browser. It's in another scene. It's in another scene, but it. See, professional. Professional. VTubing. Okay. I think that should fix it. But yeah, thanks for following. I trying to find where you are. Anyway, thank you. Um, moving on. Um, okay. Okay. Elephant. I, okay, this function visits all elephants once. Okay. A new use of undeclared identifier elephant B. There's no elephant B. Okay. For elephant B equals elephant Element, elephant, um, that letter is B. Okay, okay. I'm still trying to find where you are. uh, I um, how do I do this? Professional streamer here. Hello. um, um, I'm gonna react if it's somebody I know. Right? Anyway, okay, this is past here. Optionals. Sometimes you know that a variable might not hold a value, might not. You can use a question mark. So this is an optional. Optional is it can hold a value or not. Okay, we all know that this is it's $1 million mistake, but I think they fixed this by okay. There are language niceties here. Like this is an explicit type here. So it's explicitly value or no. So it's kind of like in I wanna say per, but I don't know per. For us is my only comparison point. And in TypeScript, you can also just union null. You can also union undefined if you really want. Certain the result so that the answer is either the integer value from the deep sum or the number 42. Um, I will threaten this. Okay, so we get or else in this. So this is expected type U8 found optional U8. So this is or else 42. Okay. Optionals 2. Um handy shortcut. It's the same as bar or else unreachable. Lead the elephants again. The elephant will solve the problem if you try and lead the elephant with nothing inclusive. Comment and see what happens. Do you think this one? Something is missing over here. Okay. Want to exit the tool. Or else break. Um, tail of elephant is null. Online for this. Online 25. Still need something. Uh, I'm not sure what that would be. Is it an optional pointer? Okay, so we have here missing elephant was null. The elephant see missing elephant that terminated unexpectedly. So we comment this. Okay, that passed. Moving on. Help, help. Evil aliens. Among Us? Alien creatures have hidden eggs all over the earth and they're starting to hatch. Can attack functions, structs, other type definitions. Function is a member of a struct that is namespace within a struct. That's called by specifying the namespace and then using the dot syntax. Dot syntax. The neat feature of these functions is that if their first argument is an instance of a struct or a pointer to one, then we can use the instance as the namespace instead of the type. Okay, what do we have here? Struct. Okay, this is similar to Rust or maybe Python as well. Mm. Bar. Okay. Okay, now you're armed. Please up the alien structs. It's a basic alien struct. Know your enemy. Hit this method hatch. Strength U8. Turn alien. Health strength times 5. Their trash and weapon. Zap those aliens C3. Love this method zap. And health equals self the damage is greater than alien that health. Alien that health. Else self the damage. It's up to 200. 120 characters here. Look at all these areas are really fine. Fine. There you go. Aliens. E3 damage equals 7. Aliens alive. Aliens alive. That alien E3 here. Oh, we have sheet 3. Heat underscore ray. Zap. The alien. Alien which is pointer to alien. Or I guess they it's just the reference. No, this is not the reference. Okay. This is a pointer, I guess. Yeah, this is a pointer. See? Alright, moving on. Now that we've seen how methods work, let's see if we can help our elephant out a bit more with some elephant methods. More elephants. Function boosting for all elephants starting with the first elephant. And following the details of the next elephant. Visit. Get there. Okay. Ooh. No. Okay, moving on. Now that we have tails all figured out, can you implement trunks? Oh my. The tail. The trunk methods go here. Okay. Just mirror the tail methods. This is spelling. I'm just mirroring the methods. We need the parentheses here. Okay. Really? Infinity! Let me find it now. What the fuck? No, no more JavaScript. No more JavaScript. Ah. Okay, so I think we already encountered this, but you can assign undefined to a variable, and you cannot read it. You can only assign to it, and if you read it while it's undefined, that's an error. Zero bit type. Why this is zero bit type? Bob example shows a variable full of type void, which is assigned a value of an empty expression. It's much more common to see void as a return type of a function that returns nothing. Okay, so that's similar to the unit type in Rust, where you have a struct that has no fields. That's the unit type in Rust. Because all these ways to express different types of no value. Please use the correct no value for each question mark to make this program bring out the cursed code from the Necronomicon, if you dare. Okay. First line is that is not. Let's say null. Null. This is this is an air.cthulhu. And second line this is an air once pointer is it how many characters is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 30, 31, 32, 33, 34, 35, 36, 37, 41. It's a 41 character string. Yeah. And it equals undefined in the first place. Or I guess you can just use this. And it's gonna be void here. Unable to infer array size. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Am I supposed to edit this? Oh, hold on. Oh, I wasn't supposed to edit that. Okay. This was undefined. This is void. This is not null. This was undefined. Okay. Moving on. If you thought that the last exercise was a good dive, hold on to your hat. Hi, Ziglings. I want to see some. Checking. No. I have to refuse. We are learning programming languages. We can't we can't learn the programming language just as the client crash. If you thought the last exercise was a deep dive, hold on to your hand, because we're about to descend into the computer's molten core. Down here. Why did I sing? The bits and bytes flow from RAM to CPU like a hot, dense fluid. The forces are incredible. But how does all of this relate to the data in our Zig programs? Let's head back up to the test editor and find out. Okay, at import and step importer go to our own in-scale code from the standard libraries editor to your program and compile with it. All of this will be loaded into RAM when it runs. And oh, no, what's the thing that we named cons STV? That's a struct. Remember our old RPG character struct, but struct is really just a very convenient way to deal with memory. Fields are all values of a particular size added together, and we have the size of the struct is not. Here we create a character called the narrator that is constant. This is a constant immutable instance of a character struct. It is stored in your program as data line like instruction code was moved into RAM when your program runs. The relative location of this data in memory is hard-coded and neither the address nor the value changes. Mobile wizard graphics very similar. Address for this data won't change, but the data itself can so far. Data cons. Function code and a particular address. Function parameters in Zig are always immutable. They are stored in the stack. Okay. Also, when a function executes, the input arguments are often loaded into the reading part of the CPU itself in the registers. Our main function here has no input parameters, but it will have a stack entry called a frame. Here, the glorp character will be allocated on the stack because each instance of glorp is immutable and therefore uniform to the invocation of this function. Glorp equals character goal 30. Or XP value is interesting, it's an immutable value. Even though it's local, it can be in the global data, in global domain, shared between all invocation. But being such a small value, it can also simply be inline as real value in their instruction code correctly used is a pattern. Okay. Okay. Now circle back to into the STD struct. Order that the club since it's just a regular club space. You can also assign meanings from its fields and declarations. Above refers to other structure, right? Is something public function names is that structure. Send the STD debug point function to const plain print. So reasons plain. Okay. Assign in values and pointing of values in Zig. Notice what gets printed in your program's output for this one compared to the other two assignments below. One doesn't output anything yet. Drop access to glorp. Drop access to the goal because 222. Drop that goal because glorp access to the goal. Glorp access to is success. Doesn't compile yet. Hmm. Okay. Sure. Cannot assign to constant. Oh, so growth needs to be uh this character access is a kind of, is that correct? I mean, you need to pass one pointer to a reference of growth. Okay. Okay. There's more. Oh, but I'm getting sleepy though. Okay, my, my eyes are drooping. Okay. This is gonna be our last exercise for this stream. Maybe maybe someone else is driving by. It's hilarious. He just wants me to ride using clankers. Crazy. We're standing here. Data segments and the stack are aren't the only eight places. Yeah, there's a heap. Okay. So if you didn't know, there's a stack and there's the heap. In the stack, you have you have very small you have very small variables basically, and those variables you basically you're performing, you're accessing them, or I guess reading and writing them on the immediately on the fly, and the heap will contain your larger variables, and these larger variables will their lifetimes are typically longer than those in stack. So that's the difference between the heap and the stack. As much as possible, you want your variables in the stack, but can't always predict if they're gonna get bigger. So if they're gonna get bigger, you might want to put them in the heap instead. So there's that. Anyway, I want to end stream right now.